Hello everybody. Thanks for coming to the last talk of the conference. My name is Rado. I work at Google. I work on the Angular team and on the team that supports the TypeScript infrastructure in Google. That's my Twitter handle, and I'll be talking about building Angular applications like Google. Google is known for scale, so there will be a lot of talk about scaling up. Everything you see here is part of Angular Labs umbrella project. So some things are kind of experimental. We want you guys to take a look at them, be excited about them. If you want to use them in your production systems, probably not the right time right now. We'll see. OK, so we're all web developers here. So are you familiar with this question? Does it happen to you? You go to your users and you ask them, do you want a very powerful application, kind of like a desktop application with lots of features, lots of power, or you want this easy-to-use application like the web? You just type the address in the URL bar, and very easy to use. So if you go to your users and you ask them what's going to happen, yeah, exactly. Kim Kardashian agrees with you. Not really, it's fake. But they will tell you, why are you asking me such a stupid question? I want them both. Get out of here. So let's flip it around. We provide tools for you guys, and we come and ask you, do you want new JavaScript features? Async await, TypeScript, type checking. Do you want all that, or you want that instant edit refresh cycle? What do you want? Well, you want both. Exactly. So let's figure out how to deliver that. So we want both, but this is what we see in the wild. We see that things start well. You feel like you have it both, right? At one end, code base is small. You set up your tooling. It looks great. Instant edit refresh cycle. Application starts to grow, and things that you didn't even think about before are starting to weigh you down. You're like, development sucks, and you're almost not sure why, but it's kind of like the tooling. You blame the tooling. That's what we see that happens if you're not careful. This is where we want to be. Like, we want, as your application scales, we increase the lines of code. We want to see you still have enjoyment building this application. We want it to be, it's going to increase, but we want the slope to be small. We want it to be gradual increase. One main thing to do as we are scaling up is we got to know when to complain. If we complain too often, nobody's going to listen to us. If we don't complain at all, maybe we really set up our tooling bad. We did the wrong setup, and something really should be complained about. So you have to know what too slow means. And to that end, what we've decided to shoot for, or target at, is 2 seconds edit refresh cycle. So this is what we're trying to achieve. We think we can do it. And I'll show you some of the tooling we use to try to achieve this, but 2 seconds, we think it's reasonable for even very large applications. And how do we know about large applications? Because we work in Google, and we do have lots of TypeScript code and lots of Angular code. We just heard from Jen about Google Cloud Console, which is a single application with 10,000 TypeScript files, and around 3,000 of them are Angular. That all of them go into one application, to one front end. And in total, we have a bunch more, but they're split amongst smaller applications. So given this scale, we think we can achieve the 2 second edit refresh cycle. And now you're asking, how do you do it? And can I do it too? And that's what I'm here to answer. All right, so how do we do it? A simple concept, incrementality. So we really have to use incrementality. What do we mean by incrementality? The size, so you make a change. The time to rebuild a project should be comparable to the size of the change you made, not of the rest of the project. Any project, no matter how large it is, you're still making small changes, one file at a time. You're still making the change. One edit at a time, you open a file, you change the file. You don't want the rest of the size of the project to weigh you down and make your builds really slow. So to achieve that, you have to use incrementality. OK. Let's do this. Let's start thinking about incrementality. We need some boundaries, like what is the unit of incrementality. So here's what TypeScript gives us: function, classes, modules. files are basically TypeScript, ES6, every file is a module. Turns out neither of them is really the right unit. We need something a little bit bigger, and TypeScript doesn't have that unit. We have to define our own packages. Right? So we need to define something a little bit bigger that contains more than one file. So we define TypeScript packages. Each package gets compiled separately. So the TypeScript compiler will execute on each package. All the dependent packages will just receive the .ts files, which describe the type shape of the package, so it can type check against it, and it doesn't need to see the actual sources. So we have packages as units of compilation, and that helps with incrementality. What do we do with Angular? Turns out Angular has this, we had this from the get-go. It's ng modules is the actual unit of incremental builds for Angular. So Angular also has an ngC compiler. Instead of .ts files, we have these ng-summary JSON files that serve the same purpose. They describe the API shape for other packages. And yeah, that's one of the main reasons why we have ng modules. So I know some of you, if you're working a smaller project, you're like, ng modules feels like this extra thing. Why do I need it? Well, they're actually the bread and butter of really big projects. When the scale grows, these are the packages they'll define the packages of your Angular application. So at this point, if you're thinking packages, all that means like, new GitHub repo, versioning, releasing, like heavy overhead, that's not what I'm talking about. I'm talking about very thin, easy to create, easy to reuse packages. In Google, we have a monorepo that all live in the same repository, so we don't have any release step as we're changing packages. They're just these units that help our build. So on average, I have around 8 TypeScript files per package in Google. I'm not saying those are preferred numbers. This is just what actually has evolved. Around 1.5 components per ng module. It's pretty low, but that's what the developers are doing. All right, now that you have packages, what do? How do you stay fast? Now you just have to follow 3 simple rules. You need to rebuild at the right time. So rebuild the right packages at every single time. No complex work done over all the sources, and keep your build tooling warm. So let's step through each one of those things. What are the right packages? When you change a file, well, we're going to rebuild the package that contains that file. We have to do that. And then there's the extra step, which is, well, has the API changed? If the API has changed, we have to rebuild all the dependent packages. If the API hasn't changed, we're done, right? So we have to do this calculation. Here's the example. So if I work on one of the modules, work on module 0, if it has the same API, I don't need to rebuild any of the other packages that depend on it. I just need to rebuild that one down here. So I'm making changes. I just keep rebuilding this one. If module 0 has a different API, I rebuild that. Then I have to rebuild the parent, because maybe the parent uses some of the methods on this package, but I don't need to touch the parent's parent. There's another scenario, which is if team 0 re-exports the API, then we have to continue this chain, and so on. But rest be assured, the rest of the build graph doesn't need to be rebuilt. So here's an example of what I mean by API change. Here's the component. This is how it looks right now. I come and make this change. I'm just going to add one more logging line in the implementation of the click handler. The API, as defined by the .ts file produced by TypeScript, hasn't changed in both cases. It's exactly the same. Therefore, the parent doesn't need to be rebuilt. The API is always just one method. It returns void. Here's another change. This is a change where I add another click handler. The API now looks a little bit different. There's an extra method. So now I need to rebuild the parent. All right, so that's kind of the reasoning you have to do every time you make changes to achieve incrementality. It's kind of, it's not so fun to do by hand. We just did it on the stage, but obviously we need a tool to do this reasoning for us, right? Maybe there'll be one at the end of the talk that does that, foreshadowing. All right, number 2, no complex work over all the sources. So TypeScript and ngC, they can work incrementally. Our build process usually is more complicated than that. We have more tooling than that, right? We have CSS preprocessors, we have minification tools, there's more. Like the real world is more complicated than just these two tools. So you're probably going to do some work over all the sources. And my only advice is don't do the complex work, right? So when you do some work over the whole project, be very cognizant of that, measure it, and don't do anything complicated there. Here's an example what we have to do in our setup. So this is the kind of the build part. The cloud is what I just showed you. This is where TypeScript works. At the end of the day, there's a dev server that has to concatenate the sources and put them on the browser. That concatenation, that's actually work that needs to be done, but we think it's kind of trivial. We can measure it. We know it's fast. That's OK. If you have a slow global optimizer, like Clojure compiler, what we use in Google, that's something that doesn't have right now a good incrementality story. It's, we just don't run it during development mode. We kicked it out of the development flow because it doesn't achieve the incrementality. Therefore, you cannot reach your 2-second SLO. And finally, this is a very straightforward trick in this business. Keep your build tools warm. If you're calling Node.js with TypeScript compiler, so TypeScript compiler itself is a Node.js program. It's turns out it's around 1.5 megabytes of JavaScript. If Node is reparsing 1.5 megabytes of JavaScript, that's not efficient. You got to keep it parsed and ready, cache the right things, and use all the CPUs you have ready on your machine. Right? All right. So what is a tool that achieves all this? That is Bazel. That is a tool that we've been using internally in Google for many, many years, like at least 10 years, and only recently has been open sourced. You can learn more about it at this really cool new top-level domain name, .build. It's a real URL. This is its tagline, fast and correct, choose to. Remember that trade-off? You really don't want to make a trade-off. Another trade-off you really don't want to make between fast and correct. You really want to be fast and correct. Bazel really tries to achieve that. It's a general-purpose build tool. It is used for all Google builds for all the languages, right? So even for Java, C++, languages that have other build tooling, we use Bazel for all of them. It is also agnostic to your version control system. It's not really tied to Git, Mercurial, or anything that we use. And why is it fast? Well, yeah, it does the three things I just mentioned. Therefore, that's how it achieves the speeds at the scale that we use it at. We've done some benchmarking. This is the URL where you can see the benchmarking, and it appears to be doing a lot better than the current state of the art, which I guess is Webpack. But disclaimer, don't trust benchmarks. What we're really more excited about is the trend line, which is, so we're going into the thousands of TypeScript sources, and it's scaling pretty nicely, like what appears to be almost linear curve. We're still very far from the SLO. The SLO is the green line here. So we have work to do. And again, the lines are always going to cross, but we're hoping to push it further than the size of the applications that big enterprises are writing. So some other benefits for Bazel. It is one build tool for front-end and back-end. Like I said, we use it for all the languages. That has some great benefits when you, for example, go and edit the data exchange format between your front-end and back-end, and automatically your build tool would rerun all the tests for both sides of the story. It's very nice, and it makes you very productive when you have that available. And it really tries to achieve hermeticity, which is a fancy word for saying whatever happens on my machine, probably the same thing will happen on your coworker's machine. So your builds are reproducible. That's a great thing to achieve, just like having your tests reproducible. This probably has happened to many of you when you pass a project to your coworker and it doesn't build, and you tell them to remove node modules or something. Yeah, that's something that's, with the right care in the build system, you can avoid. And of course, if you can reproduce it across different developers' machines, you can reproduce it in the cloud, and you get a bunch of other benefits from that. All right, do you guys want to see it in action, actually? Yeah, enough talking about it. How does this look like? All right, so here I am. So This is an enterprise application, very large enterprise application. This is my first day on the job. So I'm told I'm working on component 0. Component 0 is part of module 0, ng module 0. There are 10 components in this module. There are 10 modules in this team. And this team, there are 10 teams, and they all work on this airplane application. That there's one application that rolls all this up. So if you did the math, that means there are 1,000 components, different component types, right? 1,000 components in this application. Not very well named components. I don't suggest you name your components like this. Almost feels like a script wrote this application. I don't know why. All right, but it's my first day. I don't know what to do. How do I even build it? Well, I've been told it uses Bazel, so that's nice, because Bazel has a query language that I can just start querying the whole build and see what's happening. So let's first see how many ng modules are there in this application. All right, wow, lots of ng modules. If I see, okay, 200 ng modules. Like I said, every ng module is its own build unit, and the components are not seen here because each module contains 10 components. How do I start it? How do I start it? Well, I know that there's something called Node.js binary, and whatever the web server is, it has to be a Node.js binary. And I query it quickly, and I see there's only one Node.js binary. So that's probably the thing I need to run. So let's do Bazel build. And I will profile this into a file so we can take a look at a bunch of statistics about the build. All right, so I'm kicking off the build in a clean state. There's nothing cached right now, so there's some time. It's gonna take some time to build 1,000 components. One thing you see immediately, it's a little bit low here, but there are 3 workers happening at the same time. That's because this machine has 4 cores. One is taken by Bazel, the other 3 are immediately parallelized by the build. So it is building. This is a pretty old MacBook, so it'll take a while. While it's doing that, I want to show you the actual file that describes this build. Let's make it a little bit bigger. So this is the description of the build that I'm passing to Bazel. For those of you that are a little bit older in the audience, remember make, and all this is starting to sound like make. Good news, the syntax of Bazel is sane. There's no significant tabs. This is Python-inspired syntax, although it doesn't have significant white space. Pretty readable right away. You know, there's some visibility at the top. I import an ng module, then I say this is my module. It takes some files, and this is my tsconfig. And there's some tests. All right, let's see if this finished. All right, it did finish. It took 1 minute to build the whole application. I can look at the analyze profile. Analyze. All right, so there's a lot of information that it captured. What we really care about is I guess total time, 1 minute. There's the information here that we can poke around if we get more interested. The number of actions, this is the number of compilations that happened. I guess divided by 2, there's action to move file. So it's around 100 compilations that happened. That matches the fact that we have 100 ng modules and 1,000 components. All right, that was not very fast, but it's a big application. Let's now see the incrementality aspect of it. So what I'll do next is I run iBazel, which is the watch mode for Bazel. So now it sets up watch on the 1,000 files. So whenever any one of them has changed, it will recompile. And there it is. And I start the server. It didn't take 1 minute because all the actions are cached on disk, right? Even though I killed the Bazel and restarted it, everything is cached. And now we can take a look at this amazing airplane application. Don't get your hopes high. It's not very pretty. But anyways, there are all the components. Each one of them has its own component with its own AOT compilation, and all that happened. And I can, as a true enterprise application, I'm leveraging impact to deliver value. Yes. That's great. So I'm told I should deliver more value, though. This is my task. This is my Jira ticket. So OK, let's deliver more value. And what happens? I didn't touch anything. It automatically rebuilt and refreshed. And this took a lot less than 1 minute. I hope you, you believe that. In fact, it took 1.6 seconds, less than our SLO. Yeah. How do we do it? No magic tricks, incrementality. We just rebuilt whatever needed to be rebuilt. Everything else was reused. 2 actions taken. Like I said, there's 2-to-1 factor. There was 1 compilation that needed to happen, and that resulted in 2 actions. And this was because the API didn't change. Remember what I was talking about earlier? I only changed the implementation. I didn't change the API. So let's do one other change where we'll kind of change the API. So instead of leveraging impact, let's do something more drastic. Let's do a paradigm shift. Paradigm shift. And we'll just add one more handler here. And we will double the value. And again, I just save it. And there it is. All right. Yay. I think I'm climbing the corporate ladder. And like I said, the API changed, so we had to do 4 actions right here, which meant 2 recompilations because we recompiled the component and its parent component. And it took a little bit more time, 4 seconds, but again, very far cry from the 1 minute it took initially. And that is the end of my demo. But again, I just want to point out that there was no, this was a big application. We made incremental changes, and everything needed to be type checked was type checked. So I didn't push down any work on some integration engineer or somebody down the pipeline that had to resolve my changes. This whole application, as big as it is still completely TypeScript correct. Like it's correct as defined by TypeScript, right? So all the type checking needed to happen has happened. So there were no tricks to play or like asynchronous type checking. So like the type checking happened synchronously. Only when we were ready, we pushed it to the screen. So there were no tricks. All right, that was the demo. We used pretty weak machine with 3 workers. Turns out this demo actually, because it has a branching factor of 10, if you run it on a desktop, as you see here, it uses all the CPUs, right? It keeps scaling as much as your build graph, as much as parallelism you have in your build graph. What happens when you have even more parallelism in your build graph that your machines can have? Well, you can build it in the cloud. That's what we do internally in Google. There's a project to run your own build farm with Bazel. And actually, I think just recently, it's been announced in the Bazel conference. I think it's happening concurrently with this conference. But recently, we're announcing that you can also build in the cloud on Google Cloud. I don't have the link yet, but you can see how naturally, when you have this hermeticity, you can just ship your builds to the cloud and scale basically as much as you want. All right, that's all I had for the Bazel demo. You can find it here at this. You can find a demo and run it. There's nothing secret about, like it doesn't use anything that's not available. The feature as part of your Angular build is still a little bit experimental, therefore the Angular Labs. What we're working on right now, a bunch of polishes, Windows support, karma testing, more benchmarking. We want to change the actual Angular build on Angular/Angular. Angular is quite big as a TypeScript application itself. We want to change it to use Bazel. What we're working on maybe next year, basically, down the road, code splitting is something that we didn't use in this demo at all. Closure compiler is the optimization, the JavaScript minification tool we use in Google. It already works with Angular. It has a few rough edges that we want to improve on. and that's something that's on our roadmap to improve on. The build file that you saw, it didn't look too terrible, but we can auto-generate those based on your TypeScript imports. So we have some tooling in the pipeline to do that. And finally, expose it as kind of an experimental option as a CLI, so you guys can bootstrap with it and start using it faster if you wish to do so. If you're very excited about this, if this is like, I've been waiting to hear about this, I work on a big enterprise application, I want to start using it, you want to be part of our pilot launch, please email our DevRel, or also just talk to them, they're here, so Rob and Steven, talk to them. The Narwhal team is also here, and they're also looking into using Bazel, and reach out, and we can collaborate on using this tooling. Want to learn more? Follow Alex Eagle. He's kind of the driving force behind all this. He'll be giving this talk if he was here. I'm giving instead of him. Follow him on Twitter to get updates. This is the canonical link, not just for this talk, but for all the talks and documentation around this project. ABC, standing for Angular, Bazel, and Clojure. Bazel and Clojure being the kind of the internal Google tooling that we're exposing externally for you guys to use. And that's all I had. So thank you.